Hey everyone, welcome to lesson 3, problem 3. This is the last problem in the lesson for today. So let's dive right in. If you are realizing you are on a separate sheet of paper, that's probably fine. I'm using about 1 page per problem, but that's because I'm writing down a lot. And I'm not using the whole page because of the way the camera works. All right, so this one is called growing steps. So I see step 1, step 2, step 3. I'm gonna have to copy those down again. And step 1 says sketch the next step in the pattern. Okay, so pause the video if you haven't already and sketch out step 1, step 2, step 3, and then sketch out step 4. Once you're done, unpause the video and we'll go over it together. Okay, step 1 is this stick looking thing here. Okay, and maybe I should have started this lower. Okay, step 2, also a stick looking thing. Okay, something like that. Not being very neat, that's okay. Step 3, there's 3 across, and 1, 2, 3, 4, 5 up. 2, 3, 4, 5 up. Okay. Okay, I got an idea about what I think step 4 is going to look like. Alright, if you haven't paused the video, pause it, sketch the next step, and then unpause it, and I'll go over it with you guys. Okay, hey, welcome back. So let's talk about step 4. Well, when I'm looking at this, it looks like step 1 and step 2 and step 3, each one is getting bigger and bigger. So the question is how, right? It's all rectangles, so step 4 is going to be a rectangle of some size. The question is how big? Well, it looks like the length is growing by 1 each time. Step 1, step 2, step 3. So step 4 is probably going to be the same thing. The length is going to be, step 3 had 1, 2, 3 across, so step 4 is going to have 1, 2, 3, 4 across. Ooh! Step 4 and 4 across. Interesting. Okay. What about going up? So step 1 was, let me start annotating. Step 1 was 3 up. Step 2 was 4 up. Step 3 was 5 up. Count them. 1, 2, 3, 4, 5. So you're seeing a pattern. 3 up, 4 up, 5 up. So step 4 is probably 6 up. 1, 2, 3, 4, 5, 6. Oh, it's kind of tight, isn't it? Okay. All right, let me just draw these in. So drawing all these lines in might feel like tedious, but I think there is something like really specific about like getting your hands dirty and drawing in all these lines, because it really forces you to like think and pay attention to where the squares are and how many there are in each step. And let me write in what I noticed the first time. So step 1 was 1 across, step 2 was 2 across, step 3 was 3 across, and step 4 was 4 across. So this is number 1, right? Sketch the next step in the pattern. Great. Number 2, Kieran says the pattern is growing linearly because as the step number goes up by 1, the number of rows and the number of columns increase by 1. Do you agree? Okay, so he's noticing what I noticed. 1, 1, 1. Okay. So do you agree? Pause the video, think about your answer, write down your answer, and then respond. And then unpause the video, and we'll talk about it together. Okay, so this is question number 2, because question number 1 was step 4. So linear, yes or no? Well, they're growing by 1, which is a kind of standard linear thing. But when we talk about this, let's remember learning goal number 3. I know that in any patterns of shapes, the step number is the input and the number of squares is the output. So when we talk about the pattern, we are not only thinking about the rows and the columns. We are thinking about the number of squares. So I would say, like, if you were thinking about rows, Kieran seems to be making a good point. The number of rows is increasing by 1 each time. Cool. So is the number of columns. Cool. But what about the number of squares? Well, let's make a table. Step number of squares. And remember from the previous problem, they wanted us to give these letters. So let's think about these letters that we might use. Step number, we used n. And number of squares, we used y. We might use something different, but just something to keep in mind. So in step 1, there were 1, 2, 3 squares. In step 2, there were 1, 2, 3, 4, 5, 6, 7, 8 squares. Can you think of a better way to do this than just counting to 8, knowing that this is 2 across and 4 down? Yeah, think about multiplication. 2 times 4, 1, 2, 3, 4, 5, 6, 7, 8. Great. So what about this one? Step 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Which is the same as 3 times 5. Yeah. And in step 4, 4 by 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 4 times 6, 24. So is this linear growth? Well, remember, linear growth means we're adding by the same amount each time. So you might have already made this annotation in like previous examples. I haven't done this yet, so I'm going to do it now. So 3 to 8 is plus 5. 8 to 15 is plus 7. And 15 to 24 is plus 9. That's not a linear growth pattern. Not linear. Because the amount we're adding changes each time. So not linear because BC, different amounts being added. Bummer. So I would say no. Because the amount added is changing. Yeah. Okay, number 3. This is going to be a big one. To represent the number of squares after n steps, Diego and Jada wrote different equations. Diego wrote the equation f of n equals n times n plus 2. Jada wrote the equation f of n equals n squared plus 2n. Are either Diego or Jada correct? Explain your reasoning. So this one is going to require a fair amount of thought. So when you do this, pause the video, and this problem isn't saying it out loud, but it's asking you to think really carefully about what n times n plus 2 should look like, and what n squared plus 2n should look like. So think to yourself, can you find those things in these patterns? And then once you think you have an answer, unpause the video and we'll talk about this together. Okay, welcome back. So let's scroll up, because this is going to take some space. So let's look at what Diego wrote first. Diego wrote f of n equals n times n plus 2. All right, crash course reminder about functions. This is the output and the n's are the input. So just to clarify, this is like our y value, or this is telling us the number of squares. So this is saying the number of squares is n times n plus 2. Okay. What does n times n plus 2 mean? Well, it's multiplication. So think about everything we've looked at today. Think about how we figured out where this 24 came from, how we figured out the 15. Do you remember this? How we said 15 was like 5 times 3, or that the 24 was 4 times 6. So when Diego is describing n times n plus 2, he's thinking about sides of a rectangle. Well, I'm not in Diego's head, so I don't know. But when I see this, Diego's equation is making me think about sides of a rectangle. And so let's write this out. There's a side length n, and then there's this side length n plus 2. So he's imagining this rectangle that goes over and then it goes up. And I'm just sketching, so I'm not saying this is a good drawing. Something like that. And the n plus 2 means whatever number is down here, this one is 2 bigger. N plus 2 and n. Well, how does that describe, oops, this way. How does that describe our pattern? In step 1, is the pattern 1 across? Yeah. And is the pattern 1 plus 2 up? 3 up? Yeah. In step 2, is the rectangle 2 across? Yeah. Is it 2 plus 2 up? Yeah. In step 3, is it 3 across? And is it 5 up? Do you see where I got the 5? 5 up, 3 plus 2. Right. In step 4, you have to go back and look at your own. Is it 4 across? Mm-hmm. And it's 6 up. 6 is 4 plus 2 again. So Diego sees a rectangle, and it seems like that rectangle matches the steps, right? Step number 1, 2, 3, or 4. Step number plus 2, 3, 4, 5, or 6. Good job, Diego. Yeah. This all requires us to realize that that multiplication is describing a length times a width, right? N times n plus 2 is describing a rectangle. If you can see that, nice. You can see what Diego is seeing. Okay, let's investigate Jada and Jada's equation now. So Jada is doing something different. She's saying n squared plus 2n. Okay. But it's the same setup, right? She's saying the function, which is the number of squares. And this is exactly what's going on for learning goals 1 and 2, right? I can recognize quadratic functions written in different ways, and I can use the information from a pattern to write a quadratic function. If it's not clear, a quadratic function is anything with a squared term in it. So everything we've been doing today has been looking at quadratic functions. Did you get that? All right, so Jada, what is Jada imagining? Well, she's got this n squared business, and then she's got this 2n business. And 2n, remember 2n is the same thing as 2 times n, and n squared is the same thing as n times n, or not a rectangle, but n squared is a square. So what is Jada's equation describing? So it looks like Jada is imagining a square, an n by n square, and she is adding it to, or attaching it to, a square that is 2 by n. Right, so either 2 across and n up and down, or n across and 2 up and down. And I'm going to do it the other way, and maybe you'll see why in a second. So I'm going to do it like this. So n across, but only 2 up and down. So she's imagining there's like 2 things going on here. There's the square, and then there's a rectangle attached. So how does that compare to our pattern? Well, let's look at step number 1. So step number 1 would be a 1 by 1 square, very small, and a 1 by 2 rectangle on top. Did that happen? Can we see that? Can we see Jada's version of events? Yeah, right? Do you want me to draw it out? Let's extend our thought bubble. So step 1 is Jada's 1 by 1 square capped by a 2 by 1 rectangle. Does that work? Yeah. Okay, maybe it's easier to visualize in step 2. Step 2 is a 2 by 2 rectangle capped by a 2 by 2 rectangular square on top. Does that happen again? It looks like it does, yeah. What about step 3? Can you visualize step 3 or write it on your own? Step 3 should be a 3 by 3 square capped by a rectangle that's 3 across and 2 down. If you haven't, I would say go annotate it on your sheet and see if you can make that imagining, right? Can you imagine it as a 3 by 3 square with a 3 by 2 cap on top? And so this is it, right? This feels very almost like an illusion. Like Diego and Jada were visualizing the rectangle in different ways, but it seems like both ways work. Both ways are both correct ways of visualizing the rectangle. So that's it. If you have any questions, email me or show up at the live stream and ask questions. But until I see you again, please be safe. Please remain sane, and please remember to be kind to yourself and to each other. I miss you all. Bye-bye.